Welcome back to Let Us Learn to Lead video series on free open source software designed by M. Srinivasan, Training Associate Mathematics, Kendra Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra, dynamic mathematics software is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing a worksheet to visualize regular tetrahedron. For preparing this video lecture, I used Windows 10 operating system, a licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let me show you what type of worksheet we will be designing. We will be designing a worksheet to visualize regular tetrahedron. A tetrahedron is a three-dimensional shape having all faces as triangles. But that all the faces are equilateral, then it is a regular tetrahedron. We will take only two line segment, and then from that line segment we can get the tetrahedron directly from GeoGebra. Now you can visualize it as usual. You can rotate it and then show it to the children. Okay. Then we can give them the formula for total surface area. You can give them the formula for volume and ask them to calculate and then check out. Not only that, you can show them the net of it, which is highly interesting. You can go for this net and then touch it. You will get the net. And highly interesting because all are equilateral triangles. Now you can, when you move this, the net you can show it to the children. Okay, well, let us try to design this dynamic worksheet from scratch. Okay, well, for that, I have taken GeoGebra Classic 5 worksheet and I have selected geometry view. And in the option I have rounded off to one decimal place and labeling of new points only. Let us start with the heading. The heading should be regular tetrahedron. Now a child will, first we will discuss what is a tetrahedron. It is a three-dimensional shape having all the faces as triangles. Okay, this can be discussed with the children. All the faces as triangles. Now a question will come in the mind of the children that suppose what type of triangle it can have, what type of triangle the base can have, what type of the triangle the side, maybe the faces can have. For that we will tell them that there is a difference between a normal tetrahedron and a regular tetrahedron. We will just tell them that what is the difference. Okay. Now we will go for the next definition. A tetrahedron definition is over. Okay. We will go for the next definition. That is the definition for a regular tetrahedron. A tetrahedron having all the four faces as equilateral triangle. We'll go for this and we will declare it. And you can make it little bit bold and all of you know it. Okay. For that, the idea is very simple here. Now, if you want to have a single length of it, then you can have. But if you have it length, normally what will happen, the length what you are having will be little bit, the length may not be an integer. If you want the length should be an integer or as per your convenience, let us go for the slider. And in the slider, I am having this integer. Therefore, I will have it from 1 to 10 and increment as 1. It's not required actually, it is left to you. You can have it because you can understand. Suppose you can have this increment as 0.5 also. Will become 1, 1.5, 2, 2.5 and so on. Now we will go for one line segment simply, the line segment of the given length. I want it to be of the given length. Therefore, when I touch it A, it will ask me the length. I will give it as n, small n I think. Okay. They're becoming AB now. Now escape. I will move it and it will also move. Okay, I will keep it in a convenient place now. Now I am going to convert it into a tetrahedron. Option is available in GeoGebra. Go to 3D graphics. 3D graphics opens. The line which you have drawn here, it is visible there also. Remove this axis, remove this plane because we don't want it now. Now go to this pyramid, there tetrahedron is there. Let us see what actually tetrahedron wants. It wants 2 points, simply 2 points. Therefore touch this A and touch this B. You got the tetrahedron. And not only remember that the triangle which is formed in the left side in a two-dimensional space, the sheet should be a equilateral triangle. No need to tell you. If you want, you can check it out. The angles all are 60 degrees. Okay, you got it now. Okay, now when I move this, it is becoming big now. Okay, now I can rotate it and show it to the children. I can rotate it and show it to the children. But very simple. For all the faces of this regular tetrahedron is an equilateral triangle. Now you can go on visualizing it now. There is a formula derived for total surface area. We can mention that total surface area is equal to √3 into side square. Or we can use the latex formula. Whenever you are using the latex formula, remember the space will not come. You have to give the space. Then you have to give the space. There won't be any space between the letters, between the words. You should be careful. Okay, total surface area is √3 latex formula. Here root. Okay, then side square. Therefore SICD. Then you can go to this symbol and here you can go for square. Okay, now you need √3. Therefore here you remove it and then type 3. Okay, you see √3 into side square has come. Good. Okay, now you want to tell what is the side. For that, come back here. Therefore, length of the side is equal to, from the objects 1, you can select small n. Okay, that is the side, you know it. Okay, when I move this, that also getting changed. Okay, now let us go for including the formula now. Input bar. In the input bar, you know what is the formula for capital S now. Or TSA, whatever may be, capital S is equal to √3. How to get √3? SQRT. If you type it, immediately you type 3. Okay, what is multiplied by? What is that side? It is very simple. The side is n square. Therefore, go to this alpha and then type square. No need to type n square and so on. Okay, now that's all. √3 n square formula has come. Okay, now go back to here and then in that go to ABC text. Total surface area is equal to capital S. Just now I have made. Therefore, from here I will select capital S and keep it. Okay. Length of the side, I got it. Always press escape to come out. Total surface area, I got it. When I move this, total surface area also changes. Well, now let us go to the next formula, that is volume. Let us go to this ABC. Let us declare the formula for volume. Volume is equal to, it is having some equation. Therefore, we have to go for latex formula. First, we have to go for A by B. In the numerator, here it should be √2. Therefore, in the latex formula, go to this root. Okay. Okay. The latex formula, go to root, square root of 2 into, in the bracket, you write side, the whole square. But I think, sorry, I think we have done wrong. Okay. Volume is equal to, in the latex formula, go for A by B. Okay. In the denominator, you should have 12. Okay. In the numerator, you should have first the multiplication. Therefore, square root. Therefore, I am removing it. Therefore, in the latex formula, I am going for square root. Okay. Multiplied by SIDE, side square. Therefore, in the symbol, I am going for square. You got the side square. Okay. It should be a side cube actually, √2. into side cube. Okay, I think this also you have to change it into basic cube. Okay, root 2 into side cube by 12. Okay, you got the formula now. Okay, now how to input it is very simple. Volume is equal to, as usual, you have to go for within the bracket SQRT. Simple, very simple. Therefore, square root of 2. Okay, then star side cube. What is side cube? N cube. Therefore, N. From this alpha, you take cube and, oh, I think there's a mistake. It's a mistake. Now we will check whether that V has come. V has come. Therefore, I will delete it. Okay. Capital V is equal to, now root 2. Therefore, SQRT. Therefore, it is root 2 multiplied by star side cube. Therefore, N. Then I should have this cube. Then here divided by 12. That's all. Very simple. Press the enter. Now you got the volume now. Okay, well, now you can see whether the formula is by looking at this formula is, you see, root 2 n cube by 12. Root 2 n cube by 12. Good. Now let us come back to this geometry view now. Go to this geometry view. Again, if you go back to geometry view, then three-dimensional view will be hidden. Therefore, come back and then get the three-dimensional view. Okay. Now let us try to give the volume over here. Volume is equal to, from the object you should take that V. Good. Okay, you got that V. Okay. Okay. Now by moving this, the child can understand up to go to 10. They can 10 is a very actually a good number, because 10 cube is 1000, and then they can multiply it by root 2, and then they can divide it by 12. Therefore, they can check it out. Okay, well. Now, what is the other interesting idea about it? As I told you earlier, you can go and show them the net. How to show them the net? It is very simple. Go to this pyramid. There is a net option is there. Click it and then click it. Automatically, you will get one slider here. You slide it. You will get the net. Therefore, the child can understand the net. Highly interesting. Therefore, this is a dynamic worksheet where we have explained the children that what is tetrahedron, what is a regular tetrahedron, what is the speciality of it, the formula for its total surface area, and the formula for its volume, and then calculation by having the different sides by going on changing the side, and then visualizing the solid by rotating it, and not only that, visualizing its net also. Thank you. Let us learn to lead.